So in this video, we want to look at what we, do some practice questions as it relates to difference of two squares, or some might say difference between two squares. And so in the previous video, we looked at how we actually prove this expression. We actually prove this expression, which is called difference of two squares, to actually be equal to a plus b bracket, let me write this properly, oops, b, and we have the other one. So this is actually coming from what we call difference of two squares, and we actually proved this concept in the previous video. But let us try to understand, what does it mean to be the difference of two squares? Well, if you should look at this expression, let's rewrite it a different way. So we have a, so this is what, a square minus b squared. If you look at this, you see a takeaway sign between the two terms, and that's what we call difference. And if you look at these two terms, a square, b square, these are squared numbers, or anything being raised to 2, we call it a square. So this is actually telling us difference of two square, or the difference between two square. Because this is a square and this is actually a square. But if you should actually put any, if you should actually substitute any number into a, let's say we substitute a 2 for a, and we substitute, let's say 1 for that. Then if you look at this, if you should actually simplify this, you'll have 2 raised to the second power, that will give us 4. And then if you say 1 raised to the second power, that will actually give us 1. And so you actually see that 4 is a squared number, and also 1 is a squared number by 1 times 1. And so that's basically the concept. So we're actually using algebraic expression too, because we're not going to use number per se. We're just going to use an algebraic expression, which includes numbers, which is a constant, variables and coefficients. And so we were looking at some examples. And so if we were to actually, let's look at this. If we try to have x raised to the second power minus, let's say, 25. Well, if we were to look at this very carefully and to examine this expression, what we're really seeing is that this term is being squared, and this term is also could be looked at in an exponential form or exponent form, which would give us the same thing as this. And so we actually see the square coming out. We actually have something looking like this. Well, we could actually just write this raised to 1 and 2 there, and then we could say this minus 5 raised to the second power. And so we're actually seeing these two terms being squared, and that's what really is happening. And so we could actually represent this in the answer that we proved in the previous video. So this must look like something looking like this. If we should actually use this concept, because we could even use where's the first of all, we could actually use the what's it again, the power of power rule as relates to indices. If we were to actually get back, this is the original thing, multiply the powers and so on. And so if we were to look at this in the same concept of difference of two square, what we will get is this. We will actually get x plus 5 bracket, we will have the same thing as this. And this actually does, it actually mirrors the proof that we did in our previous video, because what we had was this. So this can be looked at in many ways. So what we had in the video was this, and we proved it to be a plus b. And so when you look at this bracket, this is actually representing that, and this and that bracket is coming from a part of the squared, where both terms in one as a sum. And so they will see a difference of it in this side, which actually be that. And so if you should look at, if you should examine it carefully, you're actually seeing that if we were to multiply this, if we were to multiply this, we should get back the same problem that we had here, which is an x squared minus 25. And so we're looking at some more examples. This was just a introduction to the concept, to some in extension or in addition to what we proved the last time. And so let's look at some more examples. So let's say I have y squared raised to the second power minus 49. And so what we could simply do, we could actually do this more than one way. We could actually say, okay, this would mirror not y plus. So I think the question is, what number would this be? What number could actually, how could I rewrite 49 as an exponent in the exponent form, or a number being raised to 2? And that number would be 7 raised to 2. And so we'll actually have 7, and we'll write the same thing as y minus. So the thing is that the brackets are slightly identical. The difference is that one will always be a negative, one will always be a positive. And so if we were to actually multiply these brackets, we would get back y squared minus 49. And let's do that. Let's say y times y gives us y squared. Y times 7 gives us minus 7y. 7 times y gives us positive 7y. And it says 7 times 7 gives us negative 49. And you can see where the middle terms will be cancelled. And so that will actually give us back our original problem. And so that's just one way of looking at it. You could look at it another way. You could actually say, you could actually solve it a different way. You could look at it like this. Let me just look at it like this, where you could actually find the square root of both terms and see the idea coming out. And so we could look at it like this. We could say the square root of that and the square root of that. So so if we should use that, cancel that, we're left with y, and then find the square root of 49, we're left with 7. And so if we have that, we know that it's going to be the opposite to that. And so it is very, 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 very simple. So let us do some more practice questions. So what if we had, let's say, w squared minus. So the first thing that we'll always, we could actually predict this answer. We could write back a w plus what number do I raise as a what base number would I raise to, what base number would I raise a square by to get 100? That would be 10. And so we just write the same thing like that. That's simple as that. Let's look at another one. Let's say I do this like this. Well, no big deal. We could just find a number that actually square that. So this will give us a 9 minus x, and we say 9 plus x. And if you should actually multiply these brackets, it will give you back the problem. And so let's do some more. A very, very not say complicated, but something that will actually challenge our minds. Now when we look at this, this is very, very simple to look at. Nothing too hard to look at this. So what we could actually do is to write these terms in exponent forms, where we can see that there's a power being raised by a base, and the power and the base, they're actually working out to give us something. So we could do something like this. We could rewrite this and rewrite this in a different way. So what is really happening here is this: 3. Because anything that what number would I raise as a raise to a base? or a base is being raised to an exponent to give me 9, and that would be 3 raised to 2. And so you could say you could do something like this. You could minus, I would do the same thing, is I would have 2y raised to 2. Well, 2y raised to 2. 2y raised to 2. And if you look at it, we're actually having two terms as a square, and now we have a difference. So that is the same concept of difference of two square. And then you could actually write this in the way that would actually give us the original thing. So we could say 3x minus 2y bracket 3x plus 2y. And we could actually prove this if this is right. We could actually go ahead and try to solve it to see if this will give us back the same problem. So we could say 3x times 3x gives us 9x. And once you have 9x, we know that something is really happening in terms of accuracy. And we'll say this 3 times that, 3 and times that. So we'll say plus 6y. We do the same thing. This 6yx. 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 I would say that times that and that times that. So negative 6yx, I would say negative 2y times positive 2y, and that will give us negative 4y squared. If you look at these middle terms, they're actually cancelling out. And so we are left back with the original, which is 9x squared minus 4y squared. So it's a very, 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 very simple concept. And you know, we could even stop here. We don't even have to go any further. It's just that simple. It's that simple, very, very simple. But we're gonna do 2 more, and then we can finish. So let's look at. Let me see. Let's look at this. Let's say this is say 2x squared minus 450. And so the first thing that we can actually do, well, when we look at 50, we know that 50 is not a squared number. But 50 is not a squared number. What we could do is to see if we could factor this expression. We could try to factorize this expression before we do anything. So what we could actually factor is, we could say we could actually factor this expression by 2. So we could take out 2 and divide it into both terms. And so we are left with y squared minus 25. And so we know that 25 is a squared number because 5 times 5 gives us 25. And so what we will do, we just leave our 2 outside, and then we just actually go ahead and work this out. So let me draw it. Let me draw a bracket like this. So we should have x, we have the y, minus 20 minus 5 plus 25. And so if we were to work this bracket out, we'll actually end up with this. And then after times this root then we get by the original term.